Unpredictable solar activity sends satellites plummeting to Earth. Researchers say last week 3 tiny Australian satellites from Curtin University's Binar space program burned up in Earth's atmosphere. That was always going to happen. In fact, Binar means fireball in the Noongar language of the First Nations people of Perth, Australia. When a satellite is in low orbit, about 2,000 kilometers or less, it experiences orbital decay as it drags closer and closer to the surface, eventually burning up. But these CubeSats, known for as Binar 2, 3, and 4, entered the atmosphere much sooner than originally planned. They only lasted for 2 months, a third of what was expected. This significantly reduced valuable time for science and testing new systems. The reason for their untimely demise: our sun has kicked into high gear, and the Binar satellites are far from the only casualty. Recent high solar activity has been causing an unexpected headache for satellite operations in the last few years, and it's only increasing. Why the sun is so active? Solar activity includes phenomena such as sunspots, solar flares, and solar wind, the stream of charged particles that flows towards Earth. This activity is a product of the sun's ever-changing magnetic field, and approximately every 11 years it completely flips over. At the midpoints of this cycle, solar activity is at its highest. While this cycle is known, specific solar activity is challenging to predict. The dynamics are complex, and solar forecasting, of course, is still in its infancy. In the last few months, indicators of solar activity were more than 1.5 times higher than predictions for this point in the current cycle, labeled Solar Cycle 25. The impact of space weather. Space weather refers to the environmental effects that originate from outside our atmosphere, mostly by the sun. It affects us on Earth in a variety of noticeable and unnoticeable ways. The most obvious is the presence of auroras. In the past few months, auroras have been visible far more intensely and closer to the equator than in the last 2 decades. This is a direct result of the increased solar activity. Space weather and solar activity in particular also creates additional challenges for satellites and satellite operators. High solar activity means more solar flares and stronger solar wind, resulting in a higher flux of charged particles that can damage or disrupt electrical components on satellites. It also means an increase in ionized radiation, resulting in a higher dose for astronauts and pilots, and potential disruptions to long-distance radio communications. But for satellites in low Earth orbit, the most consistent effect of solar activity is that the extra energy gets absorbed into the outer atmosphere, causing it to balloon outwards. As a result, all satellites less than 1,000 kilometers from the Earth experience a significant increase in atmospheric drag. This is a force that disrupts their orbit and causes them to fall towards the planet's surface. Notable satellites in this region include the International Space Station and the Starlink constellation. These satellites have thrusters to counteract this effect, but these corrections can be expensive. Low Earth orbit also contains many university satellites, such as the Binar CubeSats. Cube satellites are rarely equipped with tools that can adjust their altitude, so they're entirely at the mercy of space weather. And what happened to Binar? The Binar space program is a satellite research program operating out of Curtin University. It aims to advance our understanding of the solar system and lower the barrier for operating in space. The program began operations with its first satellite, Binar 1, in September 2021. This was less than a year into Solar Cycle 25, where solar activity was relatively low. In these conditions, the 10-centimeter CubeSats started at an altitude of 420 kilometers and survived a full 364 days in orbit. The program's follow-up mission, BINAR 2, 3, and 4, were 3 quality-sized CubeSats. However, they were expected to last approximately 6 months, owing to the extra surface area from new deployable solar arrays and a forecast increase in solar activity. Instead, they only made it to 2 months before burning up. While Cube satellite missions are relatively cheap, the premature ending of the mission will always be costly. And this is even more true for commercial satellites, highlighting the need for more accurate space weather forecasting. The good news is the sun will calm down again. Despite the current unexpected high solar activity, it will likely slow down by 2026 and is expected to return to a solar minimum in 2023. While this was not an explicit goal of the mission, the BINAR space program has now poignantly demonstrated the dramatic effects of solar activity on space operations. While the untimely loss of BINAR 2, 3, and 4 was unfortunate, work has already begun on future missions. They're expected to launch into far more forgiving space weather. And this is by conversation. Kyle McMallen, PhD candidate in aerospace engineering, Curtin University of Australia, on Science Alert. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.